That looks kind of good. Good afternoon. Okay. You're here. Thank you. Okay. Thank you, everybody, for helping me getting going here. And welcome to our machine learning cluster session. I'm Ann Wilson, and Yuhan Rao is our fellow, and welcome to our cluster. So today, I have to use preview to show you this. Today, our goals are to present what we've been working on and then identify people who are interested in contributing to our cluster efforts. And we're going to have a discussion at the end about determining our next moves and directions. So this is what we have planned for today. We have people working on different things in the cluster. Can everybody hear me? Thank you. And the person online, let me know, she's good. Okay, thank you. So I'll just give you a little bit of background. We have 3 presentations. The first is Yuhan, our fellow. His topic is machine learning applications using R and open source earth science data sets. He'll be followed by a Reef with his topic of enabling machine learning applications in earth science community through curated open source data sets. And then we'll have a demo from Sujen of the D3M machine application pipeline. But we definitely want time at the end for a group discussion about integrating these projects, maybe moving them forward, other projects that other people are interested in who are in the room, etc. So we'll use that to kind of figure out where we'd like to go with our cluster. So the background is pretty short. The idea came up a year ago in the summer ESIP meeting. Should we do this? And we said, yeah, let's do this. And we weren't quite sure where to start. It's a broad topic, experience varied. We decided we'd do a survey. So we sent out a survey to the ESIP community. Is there a problem? Okay. And here is some brief results from the survey, which unfortunately they're not ordered by what was most interesting to people, but it is the case that these here on the top are the most interesting to people. So you'll see that people were interested in an overview of machine learning algorithm types, knowing where and how to appropriately apply machine learning, and integrating machine learning into a project. It turned out that another area of interest that we didn't put on the survey, but that people were expressing, is the idea of a curated repository of training data. So what we wound up focusing on, based on who came to the cluster and what they were interested in doing, is we have a focus on introductory learning material, which Yuhan will be discussing in his talk. And then Reef and Bill have been working along with Yuhan on the curated corpus of training data sets. And then we are looking at tools, because people expressed a strong interest in tools, and Sujen has a tool that we'll take a look at. So actually, and that's really it for my introduction. And so before I bring Yuhan up, are there any questions or anything that anybody would like to say? So these talks are going to be relatively short. The goal was to have a minimum of 30 minutes at the end for discussion. I think we're going to be able to achieve that. So let's just start, and let me introduce to you Yuhan Rao.
Hello everyone, while I'm putting my slides on, I'm just briefly introduce myself. I'm Yuhan Rao from University of Maryland, and I just graduated and moving to North Carolina Institute for Climate Studies and working with people at NCEI to do climate data records for temperature. And where is I'm supposed to be the tech guy who can help other people, but I cannot do that at this moment for myself. So and today I will be discussing the effort that we're working on creating the sample use cases using machine learning in the field of earth science. And I'm really glad that Anne brought up the cluster survey we did almost 8 months ago. Yeah. And so I was trying to find the result, but I couldn't find it. So that's perfect. And so yes, this like I briefly introduced myself from University of Maryland, and I've been working on satellite remote sensing and machine learning applications. Myself, I was trained as a statistician, and so I've been dealing with machine learning for quite a while. And so just before I dive into the details about the use case initiative, that just bring up some logistic for the cluster. And so if you haven't signed up for the cluster email, you can do so on the ESIP website of the focus area, collaboration area for the machine learning. We have our monthly telecom at every third Friday of the month at 12 p.m. Eastern time. And we have a wiki page, although we do not publish stuff on wiki page that frequently, but we still update the wiki page once we have some solid resources and things we want to share with the community. And for the monthly meeting, we used to just have individual meeting notes every month, and it's through last month or from May, yeah. We started to consolidating all the meeting notes just in one document. It will be a working document where you can see in this document all the monthly meeting notes will be listed here. So, and at the beginning will be some brief introduction of the whole documents and all the information of the cluster. And we'll also identify the action items in different colors, so we can keep tracking what we are trying to do, and so we can hold people accountable. In some sense, we can like shame people with some evidence. And the last idea is that I have discussed with Anne and Megan about producing some regular update about cluster, which will be a quarterly newsletter. And so in that sense that we can summarizing the efforts that the cluster has made in the past every 3 months, and also the news that members of the cluster want to share with a larger and broader audience. So that one likely will be sent into the whole ESIP, maybe yeah, it's just a proposed idea. So if anybody has a better idea, we'll welcome your suggestions. So, and now let's get into the detail about the use case studies that we want to do. So first I want to say the what and why. So as Anne mentioned earlier in the survey of the community, that a lot of people are interested in the introductory materials. Although you can find all those tutorials and introductory materials online, but most of them are using pear and apple and orange as an example for like classification. And that's not exactly what people are looking for when it comes to the machine learning applications in earth science. So we are dealing with much different data set than red RGB band image from like a still image like that. So we have a lot of like dimension of the information that we want to include in the in the machine learning applications in earth science. So that's one of the reasons we are thinking about this initiative. But the manpower of the cluster is rather limited at the beginning. So we want to generate a proposed framework. And so everyone who want to contribute to this initiative, who can follow this framework and then contribute to this effort with your mature applications, and then just follow this framework, and then we can share with the whole community and in a much efficient way, instead rather than just rely on one or two people to produce the either Python Jupyter notebook or like R Markdown, those type of materials. And so this is just some like major component of the framework. So the first part will be describing what this use case is about. So the problem you try to solve, and then what is the data set you're working with, and then what's the challenge, and also your personal information who want to get into details about some technical questions and help, then they can try to find you to work individually. And then in each machine learning applications, that always the data exploration part is always the first step, because you're not just say, oh, I want to do this question, so I can just use a model like random forest to solve everything. You first need to understand what's the quality and what's the characteristic of your data, and then what you can achieve through those data. So exploring the data and some like pre-processing is also really necessary on the machine learning applications as well. And then after those data exploration and processing, you will then move to the next section of the training your model, and this will lead to all the parameter tuning and validation steps. Then the following the training side will be the testing of each individual model, because machine learning model can go either way, either really effective or really, I would not say horrible, but bad. So after the regular steps, there are some optional sections you can adopt, which will be the application. So ultimately, the application, it should be targeted towards some like real world applications. Since we are in the earth science community, we all have a real world question we want to solve. It's not just apple and orange, as I mentioned earlier. I'm not shaming apple and orange, but just not what we're working on. And the last part will be the added value part. So for myself, that I have been really cautious about the trend that people just want to apply to machine learning to everything. So for myself, I always want to add a section where your model, how your model can go wrong. So like when you are like overfitting your model, and then what that can lead to the real world implications. So such as when you're adding like 100 layers of neural network, how that can go wrong in some sense. And also, if you want to point people to different related resources or like further readings, you can also include them in this document. So this is basically the proposed framework that everyone who want to contribute can follow this framework. And if you have any questions or comments, you can please raise it at any moment. And so with that being said, I have been working with R for 10 years. So like I has always been focusing on using the open source library in the R, try to develop some use cases. So here I will share one use case I'm currently working on. Is a regression type machine learning model, try to predict the PM 2.5 using the data from UC Irvine. As another thing that I want to mention is that our use case effort is always trying to use open source data. So in that way, nobody will run into the problem that they cannot get data, so they cannot run your use case and stuck at the very first step. And in the use case, that's wrong file I copied. Please make a comment at this moment so I can copy the right file. So it's basically a web page where everyone can follow in the codes.
So here's something that is on my mind about machine learning that Johan alluded to. Everybody's using it. Feels a bit like fairy dust. There's definitely ways it can go wrong. And I fret about that. In fact, there's a National Academy of Sciences paper that is referred to from our website about how science is being impacted by machine learning being used poorly. So when we get to the discussion about what the cluster might do going forward, there are issues around that. Back to you, Han.
Sorry about that. There you go. So what I have been working on as the use case where we use a data set from UC Irvine machine learning open data repository. So this is a PM 2.5 measurement of Beijing, China. Do I need to increase the size of them? Yes. PM is a particle matter which it's directly related to the air quality and public health. That's when after 2010, the US embassy in Beijing have released a series of the PM 2.5 data, which raised a serious question about air quality in Beijing. And since then, Chinese government also started to monitoring the PM 2.5, which this is a really, and then not just in Beijing, now it's like in a lot of major cities, it's trying to tracking those time series data to prevent major like public health hazards because of the air quality. Yeah, I should mention that. So in that document, we also have the link to each data source and then all sorts of package we're using in the use cases. So here is just the UCL1 repository. They have really a clear definition of all their data set and description, including who is the contributor and then what's the main problem they're trying to solve with this data sets, and also the attribute information as well as the references. Can anybody tell me how I can increase the font size in Mac? Command plus. Okay, great. You can clearly see I've never used Mac before. So this is just the information about this machine learning open data repository in UCL1. And however, they only have really handful of machine learning earth science data sets in this repository. Reef and Bill have discovered much more diverse data sets from other open data sources. And Reef will touch that briefly in his presentation. And let's go back to our use case here. So first, this just showing the first section about accessing and examining the data. And you see there always the link to the data. And then since it's in our markdown, so it automatically generates a web page. And I hide the code because the code always looks nasty. But for the people who want to you copy the code directly there, you can click the code button and then automatically show you the code that you can use that and or change that to your own application. And this is just provide a visual examination of the data if you want to look at it. So this is what the data set looks like for the PM 2.5 from the UC1 repository. And since the variable name doesn't make any sense to a lot of you, so I also included the description of each variable, including the year, month, day, hour, and then the target variable will be a PM 2.5, which is concentration of the pollutants. And then some variables can be used to build a model, which is the temperature, dew point, pressure, combined wind direction, and cumulative wind speeds, hours of snow, and hours of rain. However, this data set is quite, I would not say it's quite large comparing to all those like images, but based for time series analysis, this is quite large data set. It's hourly data, so you have almost 100,000 data records. So what when I try to build a model, I don't want to build a model for like 100,000 like data records, which will take a while, let's just put it that way, to build that model. And so what I did is to aggregate the data into daily. So with the daily value, you can have a smaller data set and try to make this application work. Then just a basic visualization of the data and to see if there's any clear pattern you can observe and to justify what's a variable you want to use or you do not want to use. So here is just showing the time series of the daily PM 2.5 from this data sets. And again, that I hide the codes into making different visualization plots, and then you can modify it as you wish. And then this will be like temperature, dew points, and as well as pressure. There's like three major variables will be included in this model. There'll be other variables. And so each one, all included code, so everyone can just like modify it. And another nice thing about R Markdown, which is the package I'm using to generating this web page, is that they can also run Python code. So they have the engine can write Python in this one. So even I change the code into Python, it can automatically generate the results. And also the code, hiding the code in the same way. So it will be a uniform format that I'm using. Not I'm saying everyone should use, but I highly recommend it. And then in this case, I'm trying to build for a random forest model, which is in R doing machine learning, I always using a package called Carrot. So it's developed by Dr. Matcom. Yes, I think so. And so here I linked this like package. It's basically a wrapper package for all the machine learning package you can find in R. So, and very neat thing about this package is that it provides a uniform function. So when you try to train a model, you just train, and then you can select what model you want to use. At back end, it will grab the model from all other machine learning package you can find in R. And so you do not to know all the technical details of how to apply in that machine learning model in R. So basically, it's the same function. You just need to change some parameters like the model name. So here it's in this wrapper packages website shows how what model they have. Available models, you can find 238 models in this package it supports. So you can easily just modify one parameter in this function. You can apply in different models in your application. And So far, the result is not that promising yet, because the time series of the PM 2.5 is very time auto-correlated. So purely based on the meteorological observations, the result is not promising, so I didn't put result in yet. So I'm working on adding a lagged variable into it, so to improve the model performance based on the citation that you find from the website. So this is the major component of the application that I'm working on at this moment. And there are other two applications. One is for classification and one is for time series prediction. So before I choose this as a regression model, and then there's another time series prediction model that I'm working on. So the three will be the step point of the use cases will be distributed. So that's all I have at this moment. So if you have any questions.
Have you looked at other potential? I mean, my sense is that PM 2.5 levels are, highly anthropogenically influenced.
Yes.
Have you looked at possible ways to bring in the sources, the actual sources of the particles, proxies for industrial activity, or even, I don't know, like satellite-based aerosol measurements or other things? Because it seems like that could make it a lot more robust.
Yes, from a scientific point of view, yes, I agree with that. But since we were just building a use case, so I did not spend that much time on adding extra variables into the model. So I will just grab, because the purpose is that get what the data we have and then to build the model. Yeah, but yeah, there are a lot of people using the aerosol optical depths and then use that to estimate PM 2.5. A lot of people at NOAA and in College Park, they are doing that thing. Yeah. I'm going to bring up Reef's in the presentation. Yeah.
Okay. So again, the idea here is that this would be a framework that people could put their cases into that would be somewhat common for us to work with. And next, I'd like to introduce Reef, who will tell us a little bit about himself, including how to actually say your last name.
It's a difficult one. So.
Is it okay? And here is Reef.
Albayak, by the way. Today, I'll be talking about repositories. First of all, I'm from NASA Goddard DAC. I'm working for the data center. Okay. So I'm working for the data center, and I deal every day with lots of data, as you can imagine. And in the meantime, my background is applied mathematics, and so especially focusing on the learning algorithms. So I have been dealing with lots of different problems, including natural language processing to regression analysis and so on. So one of the major problem always we have that in the machine learning environment is to have a proper data set. As always, we say garbage in, garbage out. If you don't have the good data, then you have a problem. And furthermore, this data set has to be processed. Let's say you have multi-sensor environment and they have to be collocated and so on. So you spend a lot of time to prepare the data sets. And so you need to label them, depend on your problem. And so lots of processes in between. One of the projects I involved with about the AOD estimation, for example, it took 6 months to prepare the data set and 10 days to optimize the machine learning algorithm. So it's a very important matter to how you're going to take the data set and prepare. And the other part of the problem, our group is working with the ESIP community. And the ESIP community is a very mixed community in terms of machine learning. So we have experts, we have just beginners, and we have students. So whatever we're gonna do here as a machine learning group has to kind of reflect that in our work. So that's why we started with the use cases, which Johan already described to you, some nice applications. So when we say use case, though, machine learning use case is a little bit different than the, I will say, other subjects. A machine learning use case requires several different pieces in it, like maybe published article should be there for the use case. Maybe some type of a code that runs the data and the data. So that use case by itself is has items in it that you have to carefully consider. So what we did is that we went outside and began to analyze as a first step, look at some of the data repositories that we can pull maybe data into our system and share with the group. So some of them is the University of UC Irvine, and we look at the Kaggle is another interesting one, and Deep Dive and Gansim, and there are thousands of them out there. So finally, I decided to go back and I said, okay, if I'm a student, how I'm going to start to look at the data sets? Just let's start from the very beginning, simple. So you go to Google, right? You do your search, and lucky we have now data search in Google. Yesterday I was in the semantic group meeting, which is kind of, they spend quite a bit of time with that. So you just write there your whatever the subject is. So, and what I did, I said machine learning and agriculture. So I write the machine learning so that I will specifically pull the machine learning data sets, and that's my subject. So this page comes out. Okay, this is nice. And so let's go into one of them. One of the data set is provided there. So I went to the Kaggle this time. So this is a very classical first page of the Kaggle. They give you general information about the data set you're going to use. And some of the data sets they have, they go a little bit farther than that. And they give you, for example, each feature vector distributions in here. So it's kind of helping you. What are the distribution of the data? Depending on the models you are using, distribution is one of the most important thing, right? Sometimes you need to be close to the normal distribution as possible, and so on. So actually, Kaggle looks like they have a nice structure and it's working fine. So I say, okay, let's go to the other data repositories. So what I did, another search subject, this time UC icons. This is something Johan just showed you. The first page is this way, and once you choose the data set, what happens is that it gives you the information about the future vectors, number of the data points, and so on. So as you can see, there's a difference between the Kaggle, how they are handling the data, maybe the features and informations they are plugging into the repository, comparing to the UCI. And now, if you begin to go different repositories, this gets much more obvious. And so again, what is our goal here? Bring some data sets to ESIP community as a use case, and make it as easy as possible for the community members to use these data sets and maybe learn, maybe first step for their research. So now we began to observe these differences. This is another, bottom of the page is the information about the attributes and so on. Is the same thing, continuation of UCI. So, as I told you, I don't know how to say, let's say the problem, repositories are not consistent in terms of the information they are providing. And also we need to look into the data sets formats as well. And which is very important for how you are feeding your data into the machine learning algorithm. So how are we gonna solve this problem for ESIP? So today's subject basically is this. I will not get into any specific, I would say, machine learning algorithms, but discuss the repositories. So into our search, what happens is that then you began to see some of the APIs already written for these data sets. Now, as a person, I like to just download the data and get the information about the variable distributions especially, right? I'm interested in that. I look at the cross correlations of the data, which is the preliminary research Yuan did about the data sets. So this is provided to me. This is very nice. And there is I think right side is the Kaggle and the left side is the University of California, Irvine. And basically they are open source. They are just sitting out there and volunteers probably write. Especially the left one is written by a volunteer. And I think Kaggle provides the other one. So we can use all these Python basically based scripts to download our data sets. So that kind of gives us going towards the common app, I will call it. But still they are different in terms of how they are written. So now as a ASIP, our goal is to connect all these repositories and when it is needed so that our user can go to pull one of our script and without going all these different places and trying to figure out what is going on, just to be able to download that data with the attached information to it. Information might be what is the data about, what kind of attributes in it, and so on. So how are we going to do that? We have been discussing all along the way, creating some maybe meta files on our site, which will describe the behavior of each separate repository. And by doing that, basically what we are doing, trying to map the information from one repository to the central place where how much information we need. That's what it is. So the problem is not that simple because each data repository has multiple data sets sitting in them. So we have to have a specific interest to some data sets. So those are because our use cases for the community, and the community, when they work with the data set, they should be able to very easily include their use case in the system itself. So I just put together one simple metadata structure here for the ESIP site. So by using that APIs earlier I mentioned, we are able to retrieve information for the data set. We can do, for example, search in the repository. We can pull the attribute values depending on the API itself. So this is one of the examples. And certainly this is just very beginning. It needs to be improved along the way. Where the data set located and the information about the data set itself, maybe short explanation at the beginning. So what's going to happen here that only ESIP people will just see this part and maybe with one command will be able to pull that data to their site to do the trials. So basic flow here. So we have a small Python API, basically reading the meta file and connecting all the little pieces to each other. And at the end, you have the data in front of you. And the simple code is on the left. I borrowed that, by the way. So we have been just basically studying this ideas around. And there are lots of interesting things going on out there. Maybe some of the problems are already solved. Maybe we need to do a little bit additions to what we have as open source. So, but we have to keep in mind that when we talk about use cases, use cases is not just taking the data and throwing into the front of the user. This has to make sense in the as a whole. So you, as a use case, you have to have the connected articles and the publications and all that related information, even maybe technical documents if the NASA data, for example. And as a second thing, I think in the use case, we should be able to provide a notebook at this, like a Jupyter notebook. All day we have been studying around the ESIP community this. And so when we put together these two, it will make sense for scientists instead of recovering all that information from the data itself. And finally, providing the data, we should make that easier to the scientists. And all that combined repo idea is just the idea. Maybe someone else will come up with some other thing, which is certainly we are open to any ideas. That's why we are here today. And put this use case picture together. So this is basically my presentation. If you have any question, please. Okay, thank you.
Thank you, Reef. So just to sort of recap, we have a framework for a use case, and we're talking about a repository of data sets, and we're interested in thinking about how to bring those together. And now we'll hear about the D3M tool from Sujen.
Okay. That's fine. Or should I just make it big?
Just change it.
Okay. Okay. Hi, everybody. My name is Sujan, and I'm from JPL, working there as a data scientist for about 3 years. So this is kind of a continuation of my ESIP winter talk. And what if I tell you, you don't need to know machine learning to do machine learning? Well, this is what I said when I started my last talk in winter, and I realized that was too far out to say that at that time. But that's what the program, which I'll be talking about, the DARPA D3M program is trying to do, is trying to make an automatic machine learning pipeline systems. So I'll give a brief recap of what I did in my last talk. Would be through simple workflows. Is like, this is your typical machine learning workflow where you would have a domain expert bringing in their data, knowing what features are, selecting, like imputing, and then you might have a data scientist or like a blurred line between the expert and the data scientist that would do the model selection, train the model, evaluate, iterate over that. And then you might need an engineer to deploy it and scale it. And that's what a typical machine learning workflow would look like. What we are trying to get to is to make all of that automated. Well, you still have the domain expert, but I lose my job. Well, there is an auto ML system. So we are trying to write this part where the model selection and even part of some feature selection, the hyperparameter tuning and the evaluation is automatically done based on certain schemas and metadatas and also some previously learned information, as we call meta-learning, and then it is deployed for use. What I would like to cover in this talk, which is also in line with the focus of this cluster, is how do we bring in all these different data sets and how do we create a shareable machine learning pipeline. Like for now, if you think like, yes, I have the data and everybody takes their data and then does machine learning in like siloed institutions, how do you share that? How do you share your models? How do you share your labeled data? So what I would like to do is show some open source resources that this program has provided, and then also show a tool that is there out for us to use. This is kind of the goal of the D3M system. The user sits outside and then it is presented with a web interface. Now, there are 4 different teams doing that right now. It's just that I cannot demo their tools for now. Maybe the next talk I would be able to. We provide them data sets. The user would, as a UI, select, and we have 350 machine learning primitives that a system can search over, and also around 8,000 previously run machine learning pipelines, which these AutoML systems can learn over and then try to get an answer for users' problem. So I will show you all the resources. Okay, yeah. So all the open source resources is what I would like to share today. And also in the agenda, there is a link to the entire GitLab repository, which has my code and the presentation and all the links to all the resources that I'll be talking about today. So the D3M Core Library, I would call it like the one library to learn them all. So what it does, it basically has interfaces for different types of primitives. Like you can see clustering, distance learning, like there is featureization, supervised learning, transformers, etc. So if you click on that link, you would see that this particular D3M package is open source, and it's pretty active. It's not something that is on the shelf, like there's only a few contributors and it's not moving anywhere, but this is being actively developed since September 17, and it's a 4-year program. The missing part here was the earth science, which is where I'm trying to bridge the gap. Let's go back. So I can talk in more detail about the interfaces with people who are interested, but I would like to get through this to have a discussion at the end. So the data set schema. So we saw Johan and Arif present like how important it is to get the data set. So we have about 400 data sets, and there is a schema as to how to bring in all those data sets, which is detailed again on the repository that I shared. Let me just talk briefly about it. So, okay. So every data set has an ID, a name, a URI, a description, the license associated with the data set, and then what's the size, what am I supposed to do with it? Now, each data set, imagine if it's a tabular data set, would have columns. Each column would have a type. So we work with a lot of semantic types in our program, and there is a whole list of defined semantic types that I can get to. Each column, you would give that, and then what role does the column play? Is it an index column? Is it my target? Is it an indicator of something? Is it a location? So all of those semantic, I would say, types are defined, and we have been using it for the last 2 years, and it is developing. With that, we have a problem schema that goes with the data set that defines what type of metrics you want to have, what should be my data split, what should be my input. That again is defined here. What's the task? Is it classification, regression clustering, link prediction? You have a time series, object detection. So these are the different types of tasks that we are currently solving as a part of the program. And we could bring in more based on what you guys have. And then this, I guess, is the most important part, where we have the 350 plus ML primitives that I talked about. Now, where are they? Like there's an interface that I have here where you say you want to search, so you have to solve a time series problem. Like you want to do regression. What you would want to search? Say probably you want to use ARIMA. How do you check? Do we have ARIMA? It's like, let's search for ARIMA. Yes, we have different primitives from different teams that have been submitted. And all of these are open source, by the way. So this is not something that's very closed out to the program. And then I want to use, so what are the hyperparameters that I need to use? So you click here, and then you know what settings you can tweak with that particular primitive. Similarly, you want to do image recognition, just type image out here, and you'll find all the primitives that work with images, audio, so and so. Then we go, like this is just the UI. I put it here in case we didn't have internet. Now the next part which enables system to do automatic machine learning is to share what did I actually construct or what did I actually run. We call it a pipeline and a pipeline run schema. So a pipeline schema would be, okay, these are the steps I need to do. Okay, load my data set, extract the semantic types in the data set, impute columns, then do a classification, and then do like predictions. That's how I would create a pipeline. And then I would run that pipeline, which would create a snapshot of what exactly I ran, how much memory did I have, what CPU resources did I use, what were the values that were outputted, etc. I will show a demo of all of this. And then we come to the Metalearning Database, where this pipeline run basically gets ingested for future use, so that, say, tomorrow you want to solve a problem, you would want to see, hey, has anybody solved a similar problem? Oh, let me see, what did they use? So for example, let's look at pipelines. So we had an evaluation going right now, and there were around 8,000 pipelines that were run. You can see how many were successful, how many failed, what problem they were trying to solve. And then there are steps here which show you how did they solve the problem. Let's go here. Going to the demo, which would explain what I just said. So unfortunately, I don't have any earth science data set, which is what I am looking for from you guys to solve this. Like, this is also a common case you see in machine learning services provided by, say, cloud providers. They all tend to solve like business use cases, but not many do earth science. What we do earth science, but then again, we do it in our siloed institutions, and then there is not much communication as to how we did it. So I'm trying to solve, say, the baseball data set. It's an OpenML open data set where you have a tabular list of a player, the position where the player plays, what's his score, and we have to basically predict or classify whether the player would make it into the Hall of Fame or not. So we bring in the data set in our data schema, and then we try to create a pipeline of what we just talked about. So these are just the basic input steps. This notebook, again, is there on the repository that I've shared. We say the first thing I need to do is read my data set. So I use a primitive that does my data set to data frame conversion. And how do I know that there a primitive exists? I would just go here and in my library of primitives, just search. Is there a primitive that converts? So yeah, this is how I would know that, yes, I have a primitive that would load. I would take the name of the primitive, and as a string, just put the string here. This would then add the argument of what I need, connect the dots. Similarly, I parse the columns. Like, I'm not going into detail as to what this syntax means. This is for someone who wants to tag up with me offline. I can give a tutorial on it, but this is just going fast. And then you impute the missing columns. There are some missing columns because I've seen the data. And then what do I want to do? I use a random forest classifier, provide the string as the input, and this would basically construct a pipeline JSON. So remember, we haven't run anything yet. This is just creating a JSON version, like you see here, of the pipeline that we want to run in, say, a service that's running somewhere on the cloud. I give this pipeline to my runtime, as we call it. This runtime, again, is provided by the D3M Core package. This runtime could be running anywhere. Currently, we are running it on an OpenStack Kubernetes cluster. Many people can just submit their pipelines, and we can run and then submit it to the Metalearning Database. This is also something which we can leverage and provide as a service. This would, after running this, you can see I generated some predictions, and I also generated a pipeline run document. Now, this run document is what I was talking about, which captures what did I just run, what was the environment, how much time did I take, what were the values, what was my hyperparameters. Like, this is the exact snapshot of your machine learning pipeline run. And something which we just added as of 2 weeks is an SVG renderer for your pipeline, where we can render all the 8,000 pipelines as an SVG. And now we are working on something which is reverse, where you can construct a pipeline by using a UI, and then we can run at the back. Now, these tools are there for us to use in the cluster, since all of these are to be open sourced or are already open sourced. And this is a part of the program where they mandate everything to be open sourced. So, I mean, this is where I would end my talk, but I would open it for a discussion on how do we leverage this tool for our cluster. Thank you.
I have a question. So you're saying that user can directly go to the platform where they claim they want to do certain type of program and solve certain type of problem, and then you can automatically generate wrong pipeline. They can directly use it to cloud service. Is that correct?
Yes.
And without, so I'm not asking this question because I thought you might take my job, but
well, if you are a climate scientist, then no. But if you're a data scientist, then maybe yes.
And great, thank you. and so I always be really cautious when things are moving too fast into one direction. So when machine learning model have their own disadvantage, different model have their own disadvantage. So that's why some people choose certain model. Like for if you have really like small sample size, you go for Gaussian process because they can handle the really small sample size for the training. And but like some model will have disadvantage on other situations. So when you are saying that they can just get a output from the platform and then they do not know why this work within this data set, and that's why I'm like cautious about moving to that direction too far.
So that's where I said that when I mentioned this in my last ESIP talk, it was too far out when I said it. So I would say we would break this tool into 2 parts. One where it generates the pipelines automatically, and the other would be where we generate the pipeline using the schemas they are providing. So what I would say we should take away from the open source resources that D3M has is the schemas that they've already worked upon, so that we have a set way of trying to share our machine learning knowledge and pipelines. Like, okay, like you know that you want to use a Gaussian process regressor, for example. You do that, but you do it in a language that something that on the cloud can run. Like, you don't need the AutoML system to construct the pipeline for you. Like for our cluster right now, we don't need to go that far, but we can write in a pipeline language that can be run and rendered by systems that are already running on the cloud, so that in the future we can leverage the AutoML system as well, and we are not very far out. So yeah. So I have a question, since nobody has a question. How many of you are like actively doing machine learning on some or the other data sets right now at your institutions? Okay. And like, is there like, does sharing of this knowledge help you? Like, do you think that the thing you are doing, someone might have already done, written a paper about it, but you really cannot understand what they did? Because yeah, the code is too messy, probably, because it's research code. I think someone, yeah, do you have a question?
So this is going to display my ignorance on the topic. There's a sensitive dependence to initial conditions. The question is, if you choose everything the same way each time, does the model render the same solution, or are iterations without anything changing possibly different outcomes?
So if all your random states are the same, then it will be the same. Yes. Yeah. Well,
I guess not. Yeah, thank you, Sujan. And I'd like to start our more general discussion at this point. So let me just get back to my slides. Whoops. And again, a link to Sujan's demo is on the description for this session, so you can download that.
Hi. So I've been working with someone who's really interested in this topic, and he's pretty capable. And I was just thinking, you know, what you really want to get is you want to get training data, right? And so I was wondering if the training data sets that are being built by people, if you all have been looking at the notion of serving those data so that they are accessible over various web accessible APIs like WCS or OpenDAP. And this is shameless self-promotion. I'm the president of OpenDAP. But one of the things about, so anyways, I mean, I don't mean to make shameless self-promotion like a question into a speech. Well, actually, I would like to. But anyways, but okay, have you been thinking about doing this?
We have thought about many things.
Like that thing in particular, making training data sets available as web accessible assets.
Does anybody else want to answer that? Sure, yeah.
So this is something that when we were first coming down this road as a community, we did. It was something that your training data sets were actually very well documented or published, and that was fairly standard in the publications. Published. Well, in that case, they were an appendix on the publication, oftentimes, or something like that. Yeah, so kind of yes.
Reef, use the microphone.
But not as a service. This was so. When did we start migrating away from that? I guess would be the question, because no, they're really not anymore. At least from what they're not anymore from what I have seen in the publications.
One of the things actually as a deck, we are having a lot of discussion on very similar subject. So we have, as I mentioned, multi-sensor data, model data, we have all that things. And so we put together a small group, machine learning group, and we are basically working on how we can bring this data as a machine learning format and make it available if it's possible. So we do have some work going on that, but I don't know if there's any other data set around that they did with Earth Science. I mean, a lot of discussion going on that. So
second, James's comment here is, I think at this stage, pretty much every organization has some kind of machine learning pilot or some sort where you spend lots of time just labeling data and create that information, and you done your pilot. 6 months later, you dump everything. You know, your label data, your models is actually your golden asset, right? That the community should think about making that available, so that when you want to do another storm model or anything, you can pull that. Hey, there's this GPM label data that I can pull from, that I can continue from, rather than from scratch from every time. And it's expensive to do. So I think ESIP has definitely got the coverage where you have multiple disciplines, people that should think about. First is not so much about what the protocol to use, but more importantly is how to carry the information, how to document that information, so that, think about more like an inventory, so that the next project, the next ML project, can just leverage from that. I'm getting sick and tired of people using cats for the machine learning. Seriously.
I mean, I totally agree.
Is there a question way in the back? I guess not. Sorry. Oh.
Hi, I'm Jim Betnauer. I run the EarthML project that kind of combines the first two presenters' work. It's like the second one, it is a project with NASA Goddard, but like the first one, it's trying to capture machine learning based examples to share as starting points for everybody. And it's already online. It's at earthml.pybiz.org. I plan to come to some working group meetings here to try to coordinate. But we've definitely had a problem. What we've captured there so far tends to be relatively small data sets. We've had a big problem. We keep finding people throughout NASA who are working on ML, but we have been unable to extract publicly shareable big data sets that we could use as examples. They all talk about they want to use our techniques and we help them, but they can't give it back to us to share to the world as a fully runnable example for everyone to follow, because it's always, the satellite imagery is always covered by some license or some commercial arrangement or some other problem. Everything so far has failed to give us a good sizable data set for doing, say, machine learning of detecting buildings or counting lengths of roads or counting trees or any of the other large approaches to dealing with satellite data using ML. So what we have there is complete examples, runnable examples, beautiful examples, but they're all using relatively small data sets, not big satellite imagery. So if anybody has anything anywhere in NASA or anywhere in the world access to suitably shareable data sets, then we will be super happy to package up beautiful workflows based on them, put it on EarthML, and everyone can follow that as examples. But first we need somebody to begrudgingly give us some data.
Jim, do you have storage? You do.
We don't have infinite storage, but we do have budget, and we are funded, and we can put things there.
Great to know. Thank you.
Yeah, so a couple things. NASA's data are freely available, but I suspect at a scale that is not useful to you, because it sounds like you're working for very fine stuff. But in general, NASA's open data policy, Landsat and coarser resolution should all be openly available. Okay. The point I was going to make is kind of following up a little bit on what Thomas was saying. It's important, like we were saying, to save the procedures and the test cases and stuff like that. But the question I would have, as a manager of a data center, is what are the things that we could be doing to the data themselves to make them more mineable, to make them more available to these processes? So that's kind of the question I would have.
Yeah, one thought is with the large data sets, one thing that's really useful is just having curated, reliable labels on the data. One thing that comes to mind is if you have, like, for example, Landsat data, and the learning problem is what is the land use maps. If there's, like, for example, CalVal data that's already been done where someone has gone down to the ground and said, this actually is a forest, this actually is water, no, that's actually a wetland. That's actually labeled training data right there. So it just needs to be, and we've got lots of that. And so one question is, can that be, what needs to be done to repackage that to make that easily accessible for machine learning? Another thought is that, when you go and do the formal algorithms where you say, here is our land use map for, this particular data product, that's also a kind of labeling, although it's one level removed from, say, the ground truth. Right, and so a different algorithm might be able to come up with a more accurate example, but that's also useful.
I was going to use that as a segue, but you're so excited.
Here with one mind. So the question that kind of comes up is, like, whose labels? Okay, like how do we? You can come up with all kinds of schemes.
I see you guys facing off there, and I just want to say that I do need to. We've got less than 20 minutes, and okay. I want to switch the focus a tad. So
okay, let me just finish that question. Okay, and do you label yourself? Do we give you the option of labeling? Do we have some, curated labeling? I mean, that's kind of the question I think that we need to have answered.
I think labels have come up quite a bit. Okay, now my segue, which is, you know, we can dream and have ideas and visions and such, but there's steps in between that need time and energy, and we're a limited cluster. And so right now, in the remaining time that we have here today, I would like to hear from the people in the room what this cluster could do in more or less the near future. Of course, with an eye toward greater visions, but what should we do this year? How should we focus? And really, what resources do we have? Because what we're able to do is so dependent on who is interested in contributing and what kind of time and commitment they can bring. So that's how I'd like to focus just the next 15 to 20 minutes that we have, is what should we focus on for the next year? And so I just want to throw out a few ideas. You know, we have this great work in a framework that Johan is developing, and the notion of an interface that Bill and Reef have been working on. It makes a lot of sense to really try to bring those things together, I think, in some way. And, you know, I rather like the idea, given where we are now, of identifying a particular use case and bringing those together and actually having an output that would be this thing that kind of traces, that uses both aspects. Bill, I'm thinking of the drawing that you drew on that yellow scrap of paper, which we can't duplicate here, or can we? So basically an end-to-end kind of situation that tied together the framework and the data set repository, for lack of a better word. There are so many things we could do that are interesting. We've had a lot of talk with the semantics cluster. I don't know how many people were here on Monday for the geosemantics symposium. Thank you, yeah, thank you. So there's a lot of interesting things that could be done there, and that's where the labeling problem regularly comes up. Beth Huffer keeps telling me about, she wants labels. She'd like to be able to you know, generate labels and map them to other vocabularies and that kind of thing. So that's an area. The integration with schema.org. I'm sorry, who was talking about that? But they have issues that they need. So there's cross-cluster and committee opportunities that we could try to promote. So, and then just even farther out, there was interest by people, and I think there is interest by people in sort of the subtler aspects of machine learning, which I think is beyond our capabilities right now to start to address, but I think it's important, and it's important for our community. So I'll just put these out there. Then somebody raised the possibility, very timely, of a Funding Friday possibility. And how many people here know what Funding Friday is? Not everybody. Funding Friday is a little informal competition that occurs at every summer meeting. And the way it works is that the night before the competition, you get together and with your buddies and your beverages, and you make a poster for the idea that you would like to propose. And I believe the awards are, I'm just making a note, $3,000 for students and $5,000, thank you, Nancy, for everybody else. And you make a poster, and then tomorrow morning everybody will pitch their project, and then the people that are here will vote, and people win money to do things. So that's a possibility. So we were kind of tossing around the idea of maybe making a poster for integrating the two pieces and getting a little bit of money so that people could work on that. And then from that idea, Nancy suggested that, if we actually could produce an output, that would be something they could put into the ESIP clearinghouse training material, which, I always like the idea of something that is like a deliverable. We did this thing, and here you can go look at it and see what we learned and that kind of thing. Maybe there's another Funding Friday possibility around the notion of somehow generating labels for a data set or something like that. So I think I'm going to stop here, and I would like to hear from the people in the room, especially people that are interested in participating. What's of interest to you? How would you suggest we go forward? And what do you think we should focus on for the next year? Yes, thank you.
Well, several people mentioned inadequate training sets. And so I wonder if it would be possible to kind of spec out what would be the spec for one or more really good earth science training sets that could be used, so that, maybe if you've got something written down and shared, that could help stimulate, the creation of those better, more useful training data sets.
Thank you. This is Nancy Hobel-Heinrich. One thing that occurs to me, I have not sat in on this cluster's meetings at all, and know not much about machine learning. But in terms of goal, in terms of what the cluster wants to do, it occurs to me that education is definitely one of the goals, even though it's not been stated very clearly, at least so far, that for this cluster.
Thank you. It is education.
Okay, so it's not clear. What I would suggest is that, there's a clear discussion about what the goals are for the, for the next time. And if it's education, of course, there are different levels of it. I also heard Reef talk about the fact that there's a different level of knowledge and expertise in this cluster about machine learning. So I've heard that it sounds like there's a need for basics, teaching the basics, and maybe intermediate, where you really get a chance to solve a problem that a lot of people have but don't know how to solve. And then the whole question of bringing together data sets that could be used together in those kinds of different educational opportunities. So it seems, in terms of the clearinghouse, the kinds of things we're looking for would be something that would be a tutorial or a video presentation that also has actual activities and steps associated with it, data sets that you could pull down and use as an example and so on, that could be targeted to whichever level you wanted, but probably the basic one, the earliest level first, in order to accomplish a second purpose, which would be to pull together your community. In the cluster, you're developing your community as well, who know more about this. The more who know about it, the faster you can move forward to solving other kinds of practicable problems that you're interested in. So I would suggest trying to think about it that way. In terms of Funding Friday, you've got a use case that you've talked about already, right? That from what you were saying and what Reef and Bill have been working on in terms of how to do that. But if data sets are part of what needs to be collected, then you've got a little project right there to do that, provide those very basics first. And then you can, there are other opportunities for funding too, like ESIP Lab and so on and so forth, to move forward from that very first step. So that's my piece.
Oh, wait, I'm sorry, Karen, could you hold your thought for just a moment? Do you want to respond to that?
Yeah, very, very quickly. Actually, it is a good idea to separate the educational track from the expert track. That's for sure. And for the educational track, the part we kind of deal, it gets into both way actually, because there are lots of very nice data sets in these repositories. And if we're gonna put together some data sets which is the continuation of the articles that also gets into the expert part. But educational part is very important. And so I think we can consider both of them since they have the same core under. But how you create the data sets will make the difference for you. Maybe, for example, I work with the Modis data, collected 10 to 12 years of data, put together, collocated. There it is. This expert type of data that we should, for example, also put it out there. I don't know the resources though for now, how we're gonna do that big data sets. So we need to separate them from each other.
I'm Karen Moe, and I'm with the Disasters Lifecycle Cluster. And we've been, I have a question more on the education side of this, this group, and that is the data set labeling problem.
You know, I was just looking at, it should have been the feature labeling problem. I think I should have said, I think I phrased that poorly.
Yeah, because I was wondering if what was being labeled, was it, are you labeling material in the repository, or are you labeling the products of the machine learning process, or labeling something different yet again? Because I think we've had a continuing interest of labeling that would be associated with the data set that would give us a hint that there would be something of interest to a user who has to respond to a disaster and make a decision based on what's in that data set. But that may not have anything to do with the data set labeling problem that's described here. I can't tell.
Yeah, tell me if anybody disagrees, but I think that's a different problem. You're trying to find the right data set, and my poor wording probably was a distraction up there. The labeling problem, I'm gonna, some people can help me out here, but you've got features in your data set that you're trying to identify. So in the first, when you want to train your algorithm in the first place, you have to have a set where all those features are labeled. You know, this vector of information, it represents a cloud top height of something, and this represents, you know, atmospheric something or other. And you need to have labels on what those things are and for your training data set, so that when you apply the model to new data, it will come up with those right values of what the cloud top height is. That was a poor example, and I'm not a physical scientist, so I probably butchered it. Can somebody say that better? Okay, well, this person may.
So in machine learning, you've at least one branch of it, you're trying to learn a label from a bunch of data, right? So is this water or land, for example, right? So your data set would need to have a bunch of the data labeled as this is land, this is water, and then you're going to have a bunch of other data that's not labeled, right? And then
that you would like to get labels for.
And that's what you're trying to do. That's classification.
Yes, right? Thank you. I should say classification.
Right. So if you're working with that class of machine learning algorithm, you need data sets that are, you know, you need at least some labeled data, or you're starting from nothing, right?
Yes.
So that's one thing. And then another issue is the metadata about the problem. So what is this data set? Where does it come from? Right. What are the past 5 papers that have analyzed this data set, and what did they come up with, and what's been tried, and, you know, what is, you know, F3297 column mean, and right.
Yeah, which is a different problem.
Which is a different problem.
Right.
So, but all of that goes into curating the data set so that somebody else can use it.
Right. Thank you. What's your name?
Ben Smith.
Thank you, Ben. We have just a couple. Nancy.
I was just going to say one more thing. The other thing that occurs to me as a good possibility for a Funding Friday project would be delineating the questions that you need to ask in order to do the labeling, for instance, for a particular use case. Sounds like you've got one example already that Reef's done, but pulling back from that and turning that into something that would help people do that again in different cases, in different problems and different use cases would also be, you know, that is represented as a metadata scheme or represented as questions to ask, and that sort of thing would be might be really another interesting thing that people could use who are trying to learn how to do machine learning. So the different ways of doing it.
Just a quick comment. Earth science data is actually very difficult data to label. We have lots of data, and it's almost impossible to go one by one and try to do something. Yeah, and yeah.
You have a use case and you do it for a use case.
Sure. In the use cases, certainly we will do that. There are several different areas of machine learning which kind of indicated earlier. I mean, there are different algorithms you apply to the small data sets and create more labels or using that data sets, and some clustering techniques you can use. So there are lots of things behind the scenes. But for the use cases, especially for the education purposes, I think we should keep data sets limited with very nice labels on them. For example, we work on the precipitation data. What we do, we collect tweets and they look at the disaster-related issues, hurricanes and so on. So how you label them is hierarchical, actually. What you do first, you say precipitation, yes, no, type, one of the snow, rain, whatever, and after that, intensity you are interested in. So there it is. So you have to have a strategy to do all that stuff. And I think as a group, we can discuss that things and try to understand the problem and maybe work on the labeling and so on.
So I wonder, again, high level of ignorance on the topic, is there something in the field level or the collection level that can be done to facilitate the labeling of the data for machine learning? Or does that question not make sense?
I can take a step on that, because if you are working on the classification type problem, yes, field, like people in our department go out do field work the whole summer, just try to collecting the samples for different land cover types, land use types, because they're doing land cover, land use change using high resolution satellite images. So they spend tons of money on that, just doing the field sample every summer. Yeah.
So that's already part of.
Well, the problem is that whether they will share that to other people.
I think that may fall in the. I think that may fall in the education part as well.
Yep, true. Yeah. Well, sadly, we've run out of time. So I would like to close this by, first of all, let's thank our wonderful speakers and let's thank Reef and Sujan and Yuhan for their contributions to this cluster, which have been fantastic. That is an excellent point. We've got an unconference period coming up. If somebody proposed things, would something to follow on? Are people interested? No pressure. Well, I may or may not do that. Okay. So again, we have a monthly telecon. We would love to have more people join us. The information is available on the wiki. There's an email listserv available as well. So please do join us. If anyone is interested in considering a Funding Friday proposal, will you please stay and let's talk about that and what we might do. And have I forgotten anything? We don't have a list. No, I thought about that. Yes, Nancy. Yes. Right. So we would like talk here now, and if enough people are it is fun to make the poster. You know, it's a brainstormy, stimulating kind of environment, and sometimes you win. So please stick around if that's of interest to you, and thank you for coming here today.
It's unfair to come up with those kind of ideas so
That is just unfair competition.
Yeah, the first sentence is they may be interested in this, but when you say sign up for the wiki and stuff like that, that's a little too obscure for them.
Oh, let me get my computer and I'll show you there.
I'm gonna leave this in case you guys need it.
I'll
while
tear
you're
it off.
discussing.
Yeah, I'll take that with me. You were awesome, Ellie. Thanks a bunch.
Happy to.
The great thing, did the right thing at the right time. I appreciate that.
You could just Slack, coordinate to me.
I probably could. I do know how to get there. I did at one time. Hold on, let me just like do one thing at a time because I'm not a multitasker whatsoever. I am trying to stop preview. Preview is this one? Yes. Oh no, that's a Reef. Shoot. Where's preview? This one. Oops. Yeah, it's, is it on the drive? Oh, okay. Okay, thanks. Okay, and here, oops, come back. Try again. Yeah. Thanks so much. Hey, where's Reef? I just want to say thank you, guys. You were really awesome today, so thank you. No. No, I guess we'll probably. Which is not surprising.
I mean, yes, that's true. But in terms of
Yeah.
definitely makes sense.
And is this yours? But it's
Where was it?
here.
No.
Okay.
Is it a Reef? Could be a Reef. Yeah. Actually, we've been kind of saying that all along. That became the point last fall, that they were sort of two tracks. The issue is with this. People that are able to do.
So what's
So this has this program where they provide compute resources to students. And you can do a little project, and it's sort of the first step. There's a little money involved.
Problem is that government employee cannot receive that money.
Oh,
Yeah.
government employees.
Yeah, the government employee cannot
They
receive.
could still use the resources. Is that true?
Are resource provision by those employees?
Are you a government employee?
I am considered.
Yeah,
I
JPL
mean,
is
for
considered.
getting gifts.
Because the award.
It's gonna give you a bunch of gifts.
So do you know how to find this phone call?
Sorry?
This monthly phone call for.
Oh, yes,
person
I
that
can
would
show.
be interested?
I can show you.
But if
Fed
the resources
org.
already provisioned, then I just need to access it.
Yeah, so you can do that.
Don't get it.
So we have.
But we plan to.
I was looking at the NASA calendar, I was looking at the ESIP calendar,
Yeah.
hoping to find something, and
So if you go to the Get Involved.
so go to the page for this.
Yeah, you go to the page.
All right, you guys have a second.
Yeah.
So I gotta go.
ESIPFed.org.
How I find it. Google finds everything.